Hi, I'm Doug, and today I'm going to be attempting a repair on this nice Jamo 10-inch subwoofer behind me. Had it for about 10 years and it sort of stopped working. Let's see how we go. Alright, so initially the symptom was that the light, there's a blue light that's meant to come on at the front here, just stopped working. There was no sound whatsoever out of the unit. So I went around and had a look at the fuse, which is mounted just a little section in under the mains connector here. And sure enough, it looks absolutely totally blown. It's just all black in there. So I replaced the fuse, and then there was the second problem, which was that the light started coming on at the front, but there was a mains frequency hum coming out of the speaker. So I removed the back panel here and had a notice of these capacitors. Let's try to get some light on this. It's better. So the main signal comes in over here, or the mains power comes in over here, near this little common mode choke in the back here, and through this bridge rectifier here. And then there's these two capacitors. So these seem to be filter capacitors on the mains to me, probably just after the bridge rectifier. It's a bit of old scholastic junk underneath them, that's, or gunk I should say, that's looks it's a bit hardened. But the capacitor on the, let's see if I can get a good image of this, the one on the left there to me looks like it's bulging a little in the can. And it just looks like there's a tiny bit of electrolyte visible on top of the can there, this fellow on the left. So yeah, let's kind of investigate that a little further. So I've got my trusty Fluke 117 True RMS multimeter out to have a bit of an investigation of these capacitors. I'm just going to attempt to measure the capacitance in circuit, see if that indicates there may be a problem. So I'll get him into capacitance mode down here. And I'll push this orange switch to select capacitance mode because it's an orange. And we'll have a look at these fellows. So, turn this around. So the two capacitors actually joined here. This is a nice through-hole circuit board, very traditional, should be quite easy to effect a repair. The two capacitors are here and here, so I will have a look-see with the Fluke, and we will try to measure the one that looks good first, which is this fellow. And the meter is reading around 228 microfarads. Right. Here's the one that's not good. Here's this next one over here. The one that looks like it's got a bulging can. And no matter how much I try to get the good contact on those, it always reads 0, the capacitance. These capacitors are, see if we can get an image of this on the side here. There we go. These are 200 volts, 220 microfarad electrolytic capacitors. So this one, in circuit at least, looks like it's reading around 220, 228 microfarad. This one is reading 0. I'm almost certain this fellow is toast. So I've ordered some more nice capacitors. So I've got one of them on here. an M for Matsushita. These are Panasonic capacitors, 220 microfarad, 200 volt. Very nice, high quality capacitors. So I'll try to replace these two fellows with two of these, and we'll see how we go. So the first thing to be careful of when replacing electrolytic capacitors, it is very important to get the polarity correct. If you don't get it the right way around, they literally explode. So the negative side is usually indicated with a white stripe. It's usually got like minus signs written along it. Let's see if I can, anyway. Can't get a good view of the minus signs, but the white stripe is here we go. Yeah, is on that side of the capacitors. The white stripe running down the length of them there is on the side facing into the middle of the circuit board, not the side facing close to the edge. So likewise with the replacement ones, we want to make sure that side with the nice white stripe and the big minus sign on it is when they go in, that they go in that way in the same polarity as the ones that are being removed. So I've got a little bit of cardboard here to flick any solder on that I want to. It's not ideal, but it works well. I'll turn this over. What we need to do is remove the solder from these four pads so that we can remove these two capacitors. So I've got my trusty Weller soldering iron here. It's all heated up. Nice little touch on this fellow that was really quite unexpected was that it is made in Australia. Awesome. I'm coming to you from Australia now. There's the Australian bush. All right, so let's see if we can get these out with the soldering iron and solder sucker. So here we are on these pads now. I'm going to try to remove the solder. This one loosening up. A little more temperature for these fellows. Let's see where we go. Try one more time on that one. This one. Over here. Not the best tip on this iron. It's probably do with a flatter tip. Certainly struggling a bit in this circuit. Well, it's got some of that solder, but it's not looking ideal. See if I can get my fingers to some of these now. Try to get this one on the right here. I'm gonna go the sucker again, I think. they might have used a lead-free solder. I've turned the temperature up a little on the iron, but let's see if I can just... I've got one pin out and the other. The first capacitor is out. Now for the second one, that was the one with the leaking can. Let's try this again. Try to get that solder sucker back onto this fellow. A bit more of that up. Yeah, it looks a bit better. Let's try to get that pin out now. Looks really quite clear there. Maybe try a bit more sucking on this other one. Try again. The one pin moving and there, got him. So second capacitor is out with all of that celastic gunk. The holes over on this side look pretty clear, but not so clear on the first side. I might just try a bit more with the sucker, see if we can clean that up a bit more. Don't want to kind of rip the pads off or anything, but it does. Looks pretty good. They look pretty good now on all 6 of those. All right, so next we'll get the new ones in. Okay, well now that I've got those 2 capacitors out, the plot does thicken a bit more. Most of that celastic has just come up, and this was the good one. Looks quite good. This is the one with the bulging can on the top. It is really quite badly corroded down at the bottom here. It looks quite black, and one of the legs actually came out when I removed it. Looking back at the circuit board, it's really very, you can see it's like, it doesn't look good. It looks all scored. The green mask there has come up in places from the board. It's a bit of the celastic left, so and that pin, I don't know if you can see, it's still lodged in there. So I'm going to try to get that out and clean that up a bit. But yeah, it's certainly looking like this fellow was the cause of my troubles. So continuing with this attempted repair, I've cleaned up some of that scorching on the circuit board with some isopropanol. It's really somewhat corroded. The electrolyte is, the leaked electrolyte has caused some corrosion here. The traces seem intact to me, I'm not going to bother trying to remove that remaining bit of old Celastic there. I'll leave that to avoid causing any more damage. But one of the big problems is that on this capacitor, the good one on the right, I managed to pull the actual bloody pads and the wires out off the circuit board, which is not great. They came out on the legs of the capacitor there. So this is going to complicate things a bit. I'm pretty sure these ones are intact on the left where the corroded one is, but I've got my multimeter out again just to see if we can buzz those through. So I'm hoping that there'll be some contact between there and the point on the bottom. That sounds promising. And likewise with this one. I'm sort of flying blind here. Maybe that one's not so good. Certainly this one looks like it's meant to be connected to a point up here. You see that trace running along there. I'll see if I can get some sort of... There's a good buzz there. Oh, and there is a good buzz underneath too. So they look good, but these ones are completely missing. Now this top one is completely isolated. It's trying to isolate it from that ground plane there. But the second one here actually is supposed to connect through to this pad here. So we're going to have to find a way to bodge that in with a wire. So now let's see what we can do about getting the new ones in and bodging that in with a wire. So again, we're trying to see what we can do to get a new capacitor in while connecting the negative terminal here. You can see they've got nice negative signs on the circuit board here, so there's nothing to worry about there. We need to actually get a wire from the negative terminal on this capacitor through to this pad here. So I have found some wire wrap and a wire wrapping tool after a bit of searching. So what I'm going to do is attempt to wrap some of this wire onto the negative terminal of one of these new capacitors. So first there's on the wire wrap, I wouldn't mind just some more lengths. I'm going to use some side cutters, see if I can get some of that insulation off there. Not having much luck, come on. Come on with you. I'm certainly not a professional anything, I'm just a middle-aged man with poor eyesight. Anyway, I've got some of that insulator off there too. I do have some experience though, but and I do hold a electrical engineering degree, so it's wrong of me to say I'm just completely naive at this. All right, so let's see what we can do now to get this wrapped onto the negative terminal of one of these nice new Panasonic capacitors. So I'll see if I can thread this into my wire wrapping tool. Next to impossible with my eyesight, but come on. There you go. I thought I had it. There, I've got it now. As you can see, when it's threaded through, it comes out the side of the tool like so. And all we need to do is put the, just use a bit less than that. I want to make sure I've got enough to fill the distance out to that. Maybe that looks about right. Right. I'm trying to leave enough wire on this side to make the connection back to the pad. I might just need a little more. I don't want to push it onto the negative terminal of this capacitor and wrap it on. So that looks pretty tidy. I'll make sure I start it down a bit just so that it's not, so I'm not uptight against the base of the can there. It's all just plastic. So what I'm going to now try to do is get a little bead of solder on this just to make a good connection, and then we should be able to use this strategy to get that capacitor in and use this wire to connect through from that negative terminal through to that wire there. So I'm just going to start another video to try to get the camera in a better position. Okay, so I'm just going to try to get a bead of solder onto this wire wrapping that I just did. Got some nice leaded solder here, none of this lead-free stuff they tend to like to use these days. I'll try to just tin up the end of this soldering iron and see if I can get some without obstructing the camera angle too much. Might be a danger. Managed to. Let's see if I can see that. That actually looks pretty nice. It's not sliding anywhere anymore, and should have a pretty nice connection there. The solder should protect it from corrosion. So I'll yeah, chop this off with some side cutters. Last bit of insulator off there, and let's see what we can do with this. So I'm going to push this, the pins, the leads of this capacitor through now, and with my bodge wire pointing in the direction of that pad there that we need to connect to. Yeah. Maybe I might solder that in underneath first, and then come at the doing the wire. So we'll just pull the legs out a bit. Now this is what I was hoping to have happen, that some of that wire that I pushed through will come through the hole here. It might help me get a good, basically replace the wire. Not that it matters too much, but alright, let's get the other fellow here. Alright, good, good contact there. Come back up here and see what we can do with this little wire. I've got that on the camera, yeah. So we're going to try to connect this wire through onto that pad there. So, see what I can do. The solder is very tough to melt on this PCB. I assume it's the lead-free stuff. I have turned the temperature up a bit on the iron, but I think that's what bit me with these pads. Very difficult using a phone to take a video while you manipulate the soldering iron in, but doing the best I can. Yeah, this tip, as I said before, is not the best. It really should be a more blunt shape rather than a point. Would be more helpful. I think I've got him to melt through. It's just a matter of have I got any contact on that wire. think I've got a bit of contact there on the wire. I'll try some of my much easier to work with leaded solder to try to just get a good contact there. Yeah, it doesn't look great, does it? Cannot really see a thing. There we go. That looks pretty good to me. Let's see if we can maybe use the multimeter to buzz that out a bit. Yeah, that looks pretty good. Let's just see if there's any left on the end here. Let's poke that up. It's very difficult to see in there. Yeah, I just want to chop off that remaining bit so it doesn't cause us any shorts or other trouble. Cannot get the side cutters in there. Come on. That looks a bit better. I'll just fold what's left over back. And just grab the fluke again and see if I can get something to get some conductivity between that pad there on the top and something underneath here. Flying blind. Oh, there was something there. So, yeah, I'm touching the leg of the capacitor. It sounds very good. So let's hope that that works. And so yeah, let's move on to the second capacitor. Okay, now we're on to the second capacitor. Again, we want to install the negative terminal in the right position where the negative sign is there on the circuit board, and as we saw before, facing into the unit, not toward the edge. There we go. On this side, the pads and the wires look intact. Yeah, let's turn him over. We've got the bend the legs over a bit to hold him in position, and let's get some solder on those fellows. Looks good. That's good. We can chop off these legs. Neat. Chop off these ones as well. And we have replaced the two capacitors, including dealing with a bit of a technical issue there with pulling up the pad. So next up we'll try to see if that hum's gone. See if this has actually affected the repair. So now after all that repairing, we have the moment of truth. So I've got I just put a couple of screws in the back here just to secure it. Put back in the IEC mains connector, and I will turn on the power switch, and hopefully it won't all blow up. It sounds good. The hum I was experiencing before is completely gone, but I don't have my blue light on the front here, which is not a good sign. Let's have a look. Now there's this switch on the back in the off position. This indicates the normal mode I have it in is auto, where it automatically turns on when there are low frequency signals to play. Let's try moving that to the on position and the auto. Still no hum, and on. Houston, we have a light. Yes. So I don't know, this is all a hell of a lot better. It seems to be behaving itself so far, but obviously we have no signal into it. Anyway, I might do some testing perhaps before plugging this in, see how we go. Okay, time for some testing of this subwoofer. So I've got it turned on and I've got the volume on pretty high. In fact, it's on maximum. The blue indicates how much volume you've got, but I'll turn it all the way up. Oh, now it's on maximum. So sorry, I wasn't on maximum, but maybe turn down a bit from there. Let's maybe go about halfway. Let's try that. And I've got my trusty Rigol DG 1022 function generator. And I'm going to try to actually just inject some signals into this. So I've got the a cable going from channel 1 on the function generator through into using a little adapter into the line in on the subwoofer. So I have the, let's look at the amplitude. I'll start with the amplitude at 200 millivolts peak to peak, and let's have a look at the frequency here. I've got it at 100 hertz. Now this, on the back of this subwoofer, there's a filter cutoff here. There's a bit of a diagram of how it works here. So the frequencies that it seems to want to operate in seems to be in the range of about 40 hertz to about 150 hertz. So that's the cutoff. So it should be able to deal with frequencies even lower than 40 hertz. But to start with, I've got this turned all the way up to the 150 hertz. So I'll try to inject a 100 hertz signal into this thing with an amplitude of 200 millivolts, and let's see. So I'll turn on the output, and there is a very satisfying tone. I may actually increase the amplitude a little here. Let's try maybe 300 millivolts is sounding a bit more satisfying. Back to the frequency, and let's see what happens if we turn this up a bit. There we go. So we're at 150 hertz now, and it is sounding a little fainter to me, like that that filter we were talking about just before is maybe kicking in a bit around here. Still, I can hear quite a lot at 200 hertz, but it is starting to get fainter now as I get up to more like 260. So likewise, go down and see what we can get if we keep going down. There's 80 hertz, 70 hertz, 60, 40. Sounds very satisfying. Yes. I'm confident that this this repair has been effective. Yay! Thanks for watching.